Today we will be learning about solubility, and the first thing we must ask is, what is solubility? Solubility is the property or ability of a substance to dissolve in another substance. A few things to know is that the substance being dissolved is called the solute, and the substance doing the dissolving is called the solvent. In addition, solubility is often measured in units of grams of solute per liters of solution, or moles of solute per liter of solution. Not everything is soluble though, and luckily, many people before us have already found out what things are soluble, insoluble, and slightly soluble. So we only have to remember a few rules. These rules are as follows. Salts with group 1 elements or contain a nitrate ion are soluble. Salts with Cl-, Br-, and I- are all soluble with the exceptions of silver chloride, lead chloride, and mercury chloride being insoluble. Salts containing silver are insoluble with the exceptions of silver nitrate and silver acetate. Sulfate salts are soluble except for when they contain calcium, barium, lead, silver, or strontium. Hydroxides with group 1 elements are soluble. Hydroxides with group 2 elements are slightly soluble, and hydroxides with transition elements, or Al3+, are insoluble. Sulfides containing group 1 and 2 metals and ammonium are slightly soluble. Sulfides with transition metals are insoluble. Carbonates, chromates, phosphates, and fluorides are all insoluble. I know that was a lot in a short amount of time, so if you need to go ahead and pause the video here to take notes on these rules. Now, solubility isn't always the same. The solubility can change depending on factors such as temperature and pressure. In most cases, when a solid is dissolved in water, the solubility will increase as the temperature increases, and vice versa. This is because as the temperature increases, the kinetic energy of the molecules in the solution increase, and this causes the molecules of the solvent to be more effective towards breaking the intermolecular forces that are holding together the solute. The opposite is true for gases that are dissolved in water. As the temperature increases, the solubility decreases. This only holds true for when gases are dissolved in water, though. When they are dissolved in organic solvents, as the temperature increases, the solubility also increases. Only the solubility of gases are changed with a change in pressure, since the change of solubility with pressure in the condensed phases are negligible. The solubility of gases increases with an increase of pressure, and vice versa. Again, if this was too fast, feel free to pause and take notes on these rules.
In our lab, we tried to extract the aspirin out of a daily painkiller pill. We researched the demo and found out that aspirin is soluble in warm water and will dissolve. If it comes into contact with cold water, the aspirin will become insoluble and appear as a solid in the water. To start off our lab, we started breaking down the pills in a mortar and pestle. We chose to crush up 10 pills, so if we did it all correctly, we'd be left with 5 grams of solid aspirin. We then poured the crushed up aspirin into a beaker filled with 50 milliliters of water. We wanted the aspirin to dissolve quickly, and we knew that with higher temperatures, it would cause the dissociation rate to increase. We put the beaker on a hot plate and started to stir while waiting. While waiting for the water to reach 80 degrees, we started to make an ice water bucket that was roughly 45 degrees. We found out that aspirin was not soluble at this temperature, so we took the beaker after it reached 80 degrees and placed it in the cold water bucket. Then we waited for the aspirin to become insoluble and become a solid. Once we noticed it was done solidifying, we started to filter out the solid. We got pretty far and got a lot of the water separated from the aspirin, but there was still some water in it. The first time we did our lab, we put the mostly filtered aspirin into an evaporation dish to boil out any excess water we had. We noticed that the solid and the water would get too hot too fast and cause the water to bubble, making parts of the solid fly out of the dish. We then decided to keep all of the water in the solid in the original beaker, and it worked better to get the solid alone. Before the lab, we weighed out the beaker alone, so in the end we would know how much aspirin we were left with. When we boiled out the rest of the water, we weighed the solid and found the difference. We found it to be 5 grams, and that is exactly what we were shooting for.